Hey, it's Ryan Gordon, and I thought after the last video I did where we ported Quake 3 from SDL2 to SDL3, I thought I might do it again with a different project. Um, so I've decided I'm going to do this with DirkSimple, which if you haven't heard of this is an open source project I did. Basically, it's a Laserdisc game player, except it uses OGG Vorbis files instead of actual Laserdiscs from the 80s. If you've never heard of it, it plays a game called Dragon's Lair, among other things. If you haven't heard of Dragon's Lair before, I'm going to just show you very quickly what this looks like. This is a dude playing it. This is a camera of his controls on the arcade cabinet, and this is what the game from 1984 looked like. Now, you think 1984, you think pole position, you think the original Mario Brothers, pixelated, blocky things. This is what Dragon's Lair looked like. Watch out, Dirk. There you go. And you played that knight there. His name was Dirk the Daring. You're trying to rescue a princess. Very generic story. From a dragon, of course, because it's Dragon's Lair. But it was all handmade animation, and it was drawn by hand by Don Bluth and his team, the people who did Secret of NIMH, and it was beautiful. Cost $1 to play it in the arcade for each game, as opposed to a quarter, like everything else cost. And you never lived long in this game unless you really knew what you were doing. But it was basically a collection of QuickTime events. Anyway, enough about that. We have an open source thing called DirkSimple that has rebuilt that game logic and uses the original footage from the arcade game, but in an OGG Vorbis file. It uses SDL a little differently than Quake 3 does, so I thought this might be nice to do a second video that shows you these things. The usual speeches apply here. If you missed the first video about Quake 3, go back and watch it. It's an hour and a half long. It's a marathon to get through it, but it's full of really good information. I'm going to try not to repeat myself as much as I can here, so I would recommend you go watch that if you want. But I'll give you the very basic overview. We have this migration guide. If you're just moving from SDL2 to SDL3, this is going to give you all kinds of good information about how to do everything header by header, functions that change names, things that change that have a little easy to do things like you used to do it like this, now do it like this, blah blah blah. That's going to save your life. It's going to get you a lot of the way there. And it's also going to help you to use the migration file here, where you can go. Oh, caps lock's on. Sorry about that. There's a program called spatch. I think probably anything you're porting from SDL2 to SDL3 is going to start with this, and this will be no exception. SP file, projects, SDL, build script. Sorry, should have been more prepared. Do that. We're going to do it in the current directory, and it's going to dump out a patch file. Let's call it SDL3.patch. Before we do this, though, because this will look at every single source file, I'm just going to delete the third-party directory. There's no reason for it to look for SDL changes in OGG Vorbis and OGG Theora and stuff like that, because those are not going to use SDL. So goodbye. We'll bring you right back, but that'll save us a lot of time, because it should just have to look at pretty much just that one file right there. It's going to look at all of these, but there you go. It's done. Okay, so we should have now. Check out. Let's bring back the magic of revision control. Let's get rid of. Let's get this thing back. Third party. Yeah, it's back. Okay, cool. Let's look at SDL3 patch. Get rid of this stuff real quick. Okay, here we go. It's pretty much what you expect it to be. It's only 341 lines. This was more than double this for Quake 3, and didn't catch some things. So anyway, just to give you an idea of what we're working with here, it's a lot of, this is what was called an SDL2. Here's a patch change. It's just the thing it's renamed to, and a couple other little important catches here as we go. Like, for example, that thing right there. We're going to try and remember to look at that when things break. Okay, so let's just apply this patch and then let's get started. So yeah, I guess let's just do it. That's fine. So patch P1 SDL3, and this should just, yeah, there you go. Now I should talk about how DirkSimple is laid out here. DirkSimple is a much smaller project than Quake 3 too, just in terms of lines of code. The vast majority of the heavy lifting is done by third-party libraries. Theora, Vorbis, and OGG for the movie playback. That's all kind of makes one amalgamation of movie playback. Load PNG just to load PNG files for some basic graphics. All the logic's done in Lua. TheoReplay is just a wrapper over these things, and libretro is if you want to build the thing as a libretro core. Just use it with like RetroPie or something like that. If you want to play this classic Laserdisc game on your emulation station thing. Okay, blah-de-blah-de-blah, that's all there is to it. The basic idea is this. DirkSimple is your cross-platform C code. Lua code's in a different directory, but this just gives you the basic functionality of the thing with no no platform-specific code in it. All the platform-specific code is handled by either, in this case, DirkSimple libretro for the libretro core, or DirkSimple SDL for the standalone program. And there's a very simple interface between these two pieces of code. The platform.h thing, we'll explain it. We're not getting into the whole philosophy of this thing. I'm just running through it real fast. Basically, here's things that the useful stuff that is implemented by the cross-platform part, and then a couple of functions that your platform-specific thing implements, like how to open a file, how to allocate memory, blah-de-blah, how to get stuff to the screen. Easy stuff. And the SDL thing is a total of 704 lines total of C code, so it's really not that much code to make this magic happen. So we should not take very long to get this up and running from SDL2 to SDL3. So we're just going to start. Okay, so I applied that patch already, so... Alright, so we're already 342 lines of diff into this, that's good. Yep, looks like I applied, cool. We need to make sure, thing that will not take care of, we don't want to look for SDL2 anymore, so we're going to look for SDL3. Let me make this bigger, there we go. SDL2 include dirs. Just make that. Just look for SDL2, it's fine. Make that 3. We can probably clean that up further, but that should be all we need right now, just in terms of like build tool stuff, to make sure that it looks for SDL3 in the right place, for the headers and for the library, and links to the right thing. Easy as can be, no problem. DirkSimple does not have a copy of the SDL headers in it, unlike Quake 3, so we don't have to copy over a bunch of stuff. No problem. Let's make a directory and build this thing. Let's see here. CMake. Use Ninja so it builds faster. Build type, use release mode so it builds slower. And that should be all we need here. Oh, that's nice and fast. Okay, so we're just going to, obviously we're just going to build the thing and it's going to work on the first try. And don't be surprised, because the vast majority is the third-party libraries that we link into it. It should in fact only blow up. Something failed in there. Oh yeah, it's always the same thing to start off with. No such file and directory for SDL.h, because it's looking for the wrong thing. Let's get down to this, and let's build this in here so that we can jump to specific error lines real easily. There we go. We covered this in the last video. This is no longer SDLH with quotes. It's now brackets SDL3 /SDLH. On all platforms, that's how you do it now. I'm not getting into the long explanation again, but that's the idea. Alright, so let's see what other actual errors we have now that it'll try and compile it. Alright, things that blew up. Come back here. Let me see that one more time. So we're looking at right now, if you're looking at the counter down here, 211 lines of output. And I use this in my editor. I tend to be like, how many lines of errors did I get trying to build this, to know like how close I am to done. So we'll just start going through these and see. Mix max volume is gone. That is true. I guess before we get into this work, I'm going to just say, I said this in the last video and it's true, your greatest resource in SDL3, which has not been true in SDL2, but it's definitely true in SDL3, is the wiki, where you can punch in just about any SDL symbol and have good documentation right away about it. So if something isn't clear, you can go to a specific function, or you can also oftentimes be like, oh, it didn't like mix max volume. Let's just look on the migration guide, which is also on the wiki. You can see it up here. Mix audio format and mix have been removed because now this just takes a float. And so 1 is the same thing, so that's easy, no problem. We're just getting this to compile. You can see we're going to hit the same thing in Quake 3, where it doesn't audio spec is different now. This doesn't exist anymore. So I'm going to skip audio stuff for now because this is probably where we're going to spend a lot of our work in DirkSimple. So let's just skip by the audio pieces and look for other interesting things, and then come back to that. Create surface from makes integer from something or other. I think this is just the order of the arguments changed. Yeah, okay. That's all it is, I think. Yeah, we're in a different order now. So we have RGB, width, height, pitch, format, but it actually needs to be width, height, format. So let's get rid of RGBA. Width, height, format's that guy there. Then pixels and pitch, so that was RGBA, and then this guy is your pitch. Okay, that'll probably just fix that. We're not getting into the details of what any of this stuff does. I mean, if you're reading quickly behind me, load icon from dir is obviously exactly what you'd think it would be. Create server. Okay, let's rebuild, because sometimes you can get one line that has a thing you fix, and it fixes 20 million errors. So we're no longer at 211 lines of errors. We're now at 188. So they knock out pretty quickly here, as you can see. So just trying to skip all the audio stuff real fast here. Unknown type render info. This is gone. That's true, because the only thing people actually cared about from this thing was, where'd you go? Get render info. That's gone. So now this is it. Anytime it's like, what was the name of this renderer? Was it OpenGL? Was it Direct3D? You know, stuff like that. So let's see. What did we change that to? I think it was get renderer name. Get renderer name. Yes, we did. Okay, good. Yeah, it just returns a const char. Easy enough. SDL get renderer name. Renderer. And you can still query renderers for other things. Like if you want to know what the max texture size is, we still offer that. But generally speaking, this is what people want from there. So why make them declare a struct, load that struct up, and then pick out the one piece they wanted from it? Just easier this way. All right, full screen desktop undeclared. That's true. It's now just called full screen. And you set a mode separately on the window. But when you're just creating the window, if you use that flag, it means full screen. What full screen desktop meant in SDL2, because the default video mode is the desktop mode for any new window. So you just take that out. That's easy. We'll see what else is broken in here. Let's see. Creating a renderer. Oops, that was a mistake. Lost my line. Sorry about that. I'll never find that again. Oh, there it is. Okay. Too many arguments to SDL create renderer. That's true, because it's only 2 now. But I'll show you as we go. Yeah, it's just a window and an optional name. It's no longer an index into the list of drivers. You actually just say, I want OpenGL if you want it. If you don't want anything, you just ask it for null. And these flags are gone. You can set them yourself if you want, but the default one we decided easier was better. Alright, so if that fails, we don't need to try again. Got to create a renderer. Cool. I can already tell show cursor is going to go because this is no longer a true or false thing. False is now called hide cursor, so we'll just save ourselves the trouble of, yeah, too many arguments function show cursor. There you go. Implicit declaration of function. Okay, we skipped ahead to that. Yep. More audio stuff. Render texture. Oh, okay. Textures, generally speaking, when they do rectangles, when they're talking about rectangles, they're floating point rectangles. And the compiler will probably just implicitly promote this to float, but let's be explicit because there's going to be some compiler that'll be mad, throw a warning or an error. Alright, so same thing. It's just instead of the rectangles that you can specify for textures where they get drawn from in the texture and where they get drawn to on the screen, instead of them lining up on pixel boundaries, you can do sub-pixel precision now. So that's all that needs there. We only care about the pixel precision. You can do it if you want, but we don't need it for this particular task, so we'll just do that. Cool. Everyone's favorite problem from Quake 3, that the keyboard symbol gobbledygook name changed here. So now it's just E key. You can literally just cut off the end of it. I see another one down here, so let's get that one too. Got any more for me? Oh, that might be it. Okay, that's good. Well, nope, I see one. Tried to sneak up on me, but I was ready for you. Alright, let's try that. Keyboard event. There's full screen desktop again. I think window full screen just takes a bool now. It does. Okay. In SDL2, set window full screen to toggle an existing window between full screen and not. You had to give it a flag because you could be saying full screen or full screen desktop, but now it just takes a boolean to say I want full screen or not and use whatever mode I set for this window. And this is thankfully gone. You're probably wondering why it does this. I mean, obviously this thing wants to flip it from between true and false as a toggle, so we can just do this. But what you're looking at here, the reason it did that is almost certainly because at one point, before that script ran, this probably said SDL false, SDL true, and it cleaned it up for us. So into real like bools and falses, trues and falses. But now you can just do that, flip it. Set the window, blah, blah, cool, okay. Another one of these, I got that one. D-pad up, renamed. So I don't know if you've noticed this, I don't know if this popped up in the Quake 3 video, but oh, okay, the conversion script didn't change this symbol to the new one because it's got C preprocessor magic symbol in there. It did not recognize the pattern. That's okay. We're going to fix it right now. But you might have noticed this, that we have all these symbols in the SDL3 headers in a file called sdloldnames.h, where we define a lot of SDL2 symbols that have been renamed to be called this, so that pops up right as a compiler error to tell you exactly what you had and exactly what you need to change it to. And you can turn that off if you don't want a bazillion symbols in your compile. But by default, it's on, and it's super useful for just this reason. D-pad, controller button, D-pad up is now gamepad button, D-pad up. All right. So it's just controller became gamepad, so let's fix that real quick. Gamepad. And I bet this is probably now game controller get button. Let me go look at my migration guide for a moment here. Game controller get button is now get gamepad button. Okay. Done. Okay, cool. And that was probably a whole bunch of errors for each of these iterations of this macro, but that's probably fixed now, so cool. Yeah. There we go. Good. Yep. And then, of course, I can see already that it caught one of these where most of the SDL functions that returned -1 now return true and false, because that makes more sense. So you can just go if not init, if init failed. Sounds more like human language. So, and since it's now returning a bool, trying to compare it to -1 upsets the compiler, so it alerts you immediately that there's a problem, which is super nice. And then we have okay, get base path in SDL2 does the same thing, but it would malloc a string and return it to you, so you had to free it afterwards. Whereas now it returns a const pointer because the base path doesn't change during the course of execution. So now we calculate it once and we just cache that value and keep giving it back to you, and you don't free it. So, and I can see that above this we have a hard-coded string that we're string duping. We don't have to do that anymore because this is going to be a const char, and this will also be a const char. Why make a copy of it? We're only making a copy of it because if you weren't on this path, you definitely had to free it, and here you would. It makes it so you'd have to free it there too. So we don't want to do that. Let's do that. Let's just make sure we don't free this anywhere. Baster. Ooh, okay. Talk about that later. Okay. Uses it, and then it frees it, so definitely don't free it. And that's the last time we use it. Okay, cool. All right, let me rerun this build. We were at 188 lines of errors. Let's see where we're at now. We are at 79, so like that was the vast majority of it. And now I think we are... Oh wait, no, there's a joypad thing. Let me see. Oh. Gamepad button A. We changed these. Let me go find that real quick. What was it called now? Button south? Yeah, okay. Since these are meant to be positional buttons, we stopped naming them after Xbox controller buttons, so you'll see we left a comment here, which was nice of us. Xbox A is now called south because it's the lowest one in that diamond of buttons, so button south. Okay, so A is now called south, and X was it X? Yeah, X was west. Yeah, there we go. Good. That'll probably fix that. Cool, let's run this one more time. Alright, now I think we're entirely, and 60 lines of errors to go here. I think we're entirely into audio stuff, so let's run through this real quick. Alright, samples is gone, callback is gone from spec. That's just gone, we don't need that anymore. So the way that DirkSimple works right now, we keep an audio stream in SDL2 that as once this function gets called in the platform-specific code, saying, "Hey, we now know what format the Laserdisc or the OGVorbis, the OGTheora file is going to be. So this is the data format you should expect it to be." Now you can set up things like your audio device and other things you're going to need to make sound playback happen. So we come in here and it opens up an audio stream, so that as DirkSimple, let's see if we have this somewhere nearby. There it is. Every time DirkSimple gets more audio data from the quote-unquote Laserdisc, it calls this function, and we stuff it into that audio stream. And then when we need more data played, we just play it. And then when it changes scenes, like it seeks on the imaginary Laserdisc to some other position, it'll call this, and we nuke any buffered audio we have from this. And audio streams can convert data, but DirkSimple has it set up so that it doesn't have to do that conversion at the platform layer to keep it simpler. So all you need to do is just basically use this thing as basically a stream of audio, a literal stream where it doesn't need conversion. It's just buffering between more data coming in and more data going out. So that's pretty straightforward. Let me go back to where I was here. Oops. Audio format. Okay, so when it tells us what format it wants to play sound in, we set up that stream so that we can just keep a buffer of movie audio. And then we also open the audio device. And then, I already deleted it from up here, but it had a callback. Let's go find that real quick. Audio callback. I can't spell. Audio callback. There we go. And what this does is it'll say, like SDL2's audio callback did, it would say, every time I call this relentlessly, I need this buffer filled with this many bytes of data, no takebacks. If you don't have the data available, you got to write silence to it. So this audio callback would come in, pull any data out of that buffer that it had already, the audio stream of what the Laserdisc is supposed to be playing, and write that right to the memory buffer, as many bytes as it wants. And if it got less bytes than was needed, it fills in the rest of the stream with silence, because the stream is always in float 32, in DirkSimple's case at least. And then it has a magic link list of other sound effects that are playing, like bleeps and bloops, like when you put a imaginary coin in the imaginary coin slot in the imaginary arcade game you're playing, Dragon's Lair would make a bloop sound. And when you make a right move or a wrong move, it'll buzz or beep at you. So, as those things are being played, we keep a linked list of them, and then we just come through here and keep mixing each of those playing sounds into the audio buffer that we filled with the Laserdisc. So we mix some other audio on top of that until we run out of sounds that are playing in the linked list. We free things from the list as we finish playing them. And by the time you get to the end of this, you should have a fully mixed buffer that you can hand to the audio hardware. No problem. Let's get rid of it. Well, Well, let's keep this for now. Let's just bump this up to how SDL3 would do the equivalent of this, just to simply get this running for now. So we have open audio device was the thing. There we go. Okay. So we still want to keep this buffer, this audio stream that keeps track of Laserdisc audio. I'm going to keep saying Laserdisc, but it's literally an OGG Theora video file. But if this were the 80s, it would be coming off of a Laserdisc, which was kind of a precursor to like DVDs. It was actually analog, even though it did use a laser. It's pretty interesting. Just these big honking Laserdisc players inside these arcade machines. Just a wild, clever idea for the time. Okay, so instead of opening an audio device, let's just do this the simple way. Let's just do the straightforward SDL2 to SDL3 conversion, where we have audio device ID. Let's go look for that real quick. Audio device, let's find all the occurrences of this. And I'm going to keep this name for now, because I have a different plan later. But instead of this being a device that we open, let's turn this also into an audio stream, because the easy way to do this, the easy button for moving from SDL2 to SDL3, is to use SDL Open Audio Device Stream, not Steam, which will basically take care of managing the audio device and also just giving you a stream that you can use to fill in data for it. Although these parameters are different, so let me look up what that is real quick here. So I get these wrong every time. Okay, so it's the device ID, the spec, the callback, and user data. And you can open a specific device ID, you can enumerate them, and see what's available. But generally speaking, you want to open this audio device default playback, which will say you figure out what the system thinks is the best thing to play on, and if what the best thing to play on changes while you're using this, just switch to the new hardware without alerting me at all. I mean, well, it sends an event, but you can just keep playing and it will figure out the difference for you without bothering your program if you don't want to be bothered about it, which is nice if someone wants to plug in headphones, or they yank out their USB headset, or they just change a system default in the system control panel. This is generally what you want, unless you absolutely positively need a specific device. Like, you want to play your audio to the sound card, but you want to have like voice over IP go to like, you know, a USB headset or something, and so they're separate devices. That's the only time you should really not be using this. Alright, so device ID, we just want the default. Spec is whatever format you want this in. We have a spec, so here, it's spec. There we go. And then callback, we had one of these. We'll just continue to use it. This is optional. If you just want to push data to the stream, you can do that. But being that we're coming from SDL2, that has an audio callback, we'll continue to use that for now. And then user data is null, and I think probably it was here too, so cool. Okay. If audio device ID, which is no longer actually a device ID, it's now an audio stream, so whatever. Device opens, failed, going on without sound. Yeah, that's fine. Okay, cool. And then resume audio device, you would have to do an SDL2. It would actually be called pause audio device, but with a false parameter. That got changed by the script. That's good. You got when you do this, it starts pause because the callback might be firing right away. So you have to call resume before it'll actually start doing work for you. Resume audio stream device, because that's just a little helper function, so you don't have to find out the device ID from the stream. You already have it. Done. Okay, so that should fix that up. But let's keep looking for audio device ID. Disk audio, lock audio stream. All audio streams have a mutex built in that you are allowed to access in this very way. So we'll keep doing that, and it's good to lock there because that'll protect it while you're, in case the callback fires while you're doing this, which is exactly why these are here. So yeah, we'll just keep doing that. Lock device. There is no locking of devices though, since streams have their own mutexes in SDL3. Unlock. Yep, cool. That puts audio data to it. Okay, that clears it. Cool. Although, you probably actually don't have to lock the audio stream because the things that you're locking against are also going to hold that same lock. So There. It's a little easier. It's easier. It's easier. You don't have to do anything with it. Close audio device. This is now a stream, so you want to call destroy audio stream. I have this commented out because we're going to come back to this in a little bit, but since we opened this stream, created this stream with the magic thing that opens the device into the stream at the same time, it will close the device for you. So that'll take care of that problem for you. Playwave. Okay, this is where it goes when the cross-platform section is saying it's time to play a new thing, and that's where it sets up it adds a new item to the linked list. And since that's touching a linked list that the callback thread's going to, this we will actually keep the lock for. There you go. And that's it. That's all the times we touch that. So maybe all we need to do now is update the audio callback. Is that right? Let's find out. Okay, so that's what an SDL2 audio callback looks like. It looks a little different in SDL3. Drop this in here real quick. Static void SDL call. Still call it audio callback. There we go. Okay, so it used to be this buffer, this many bytes. Now it's this audio stream. This is how much more I absolutely need right now. This is the total amount I'm asking for in case you want it. But we don't actually care about that at all. So for simplicity, const int len equals additional amount, so I don't have to change this code. It's already looking for len everywhere. We're going to do something gross here. Don't worry, we're getting rid of this. Don't worry. But uint 8 pointer 8 buff equals uint 8 pointer SDL malloc. We need a buffer to write to because we're going to do a bunch of mixing, and then we're going to put it into the stream, which is not a raw buffer. It's now an object you have to put stuff to. So len, there we go. If UI8 buff. If this fails, oh well, too bad. What are you going to do? You probably have deeper problems if malloc fails in any case, but that will, in the case of SDL3, it'll just be, you'll just start playing silence. It won't cause corruption. It'll just be like, oh, I didn't get more data. We're out of luck. It'll try again later, too, so if it fails. Okay, so this can't get to a thing called stream because that's called something else now. So put this right into UI8 buff. This is really gross. I'm just saying this up front because, you know, this is just a temporary thing just to get this running. You probably do not want to be calling malloc in every audio callback, SDL2 or SDL3. But that's just what we're doing now, just to make sure we have a buffer. Okay, so we get the data from the laserdisc, put that into the buff. This is UI8 buff plus got. Parts of the buffer that we did not have enough laserdisc to fill, we will just write silence to. So now we have a fully initialized buffer that's got any available laserdisc audio in it. And then we go through our list of other things we need to mix in on top of it. Done. This is not stream anymore. This now needs to be UI8 buff. Done. Yeah, that looks good. And then it mixes it. Does all these things. And then at the end here, the callback is entirely advisory. You don't have to do anything with it, but obviously you want to. So put audio stream data stream, the callback was called for, UI8 buff, and len. So the amount it asked for is what it got, even if it might be silence if we were running behind, but that's okay. Then free that buffer because we do not need it anymore. The audio stream, we put this data to, made a copy of it. And that's that. Now that seemed like a lot of talking, but if we're being honest, most of this callback did not change. The code of it didn't change very much, so we're kind of sitting pretty here. We had to make this ugly concession, and frankly, we could probably stack allocate that to make it less gross, or just, you know, reallocate this just when the buffer size has gotten bigger unexpectedly or something like that. But that should get that going. Let's compile it and see what else is broken, but that might be most of the work. Oh, very close. Okay. Create audio stream. This now actually just takes a spec and a spec, because this is just the data twice. So, and since we're not converting, it's input format, output format. But since we're not converting, we're just literally using this to buffer data from the Laserdisc. You just put the same spec twice. That works. That's legal and cool. Everyone's happy with that. Oh, and that was it. That was the last bug we had there. All right, so let's go look at this in the terminal. And there it is, DirkSimple. It is an ELF binary. Okay. DirkSimple grep needed. And it only links to the C library, the math library, and SDL3. So this is an SDL3 binary now. Let me copy. There we go. You have the file there. DirkSimple layer for Dragon's Lair. Let's see if it works. Oh.
Dragon's Lair.
Dragon's Lair.
Adventure where you become a valiant knight on a quest to rescue the fair princess from the clutches of an evil dragon.
I just love that guy's voice. I don't know. All right. Okay, so I just started. Keyboard import's working. Audio is obviously working with Laserdisc. Let's get some beeps. That's me hitting wrong moves. Oh, I left the cheats up here. That's good. Oops, that hurts. Okay. Let's get rid of the cheats because it's draw hints, I think that's called. Try that one more time here. But yeah, beeps. Obviously those are mixing. Those are wrong moves. You'll hear a doink when I do a right move in a moment. You want to get across this without dying. Gotta make sure your hand's extended. Oh. I'm not good at this game. I don't know. I'm not gonna lie to you. Definitely never drink that. It'll kill you. See, that was an easy level. Okay, anyway, so that's working. So as a very basic thing, we're 35 minutes into this, and we've moved this thing from SDL2 to SDL3. Easy peasy, it's working great. But the real reason I wanted to show you DirkSimple was that in Quake 3, we just did a very basic port from SDL2 to SDL3. But with this, I want to show you some other features of SDL3 that we could use to improve our quality of life, or add features we were kind of cheating about before. So the first thing that's bothering me about this this source code is this thing right here. This line, Windows, lean and mean versus dir. Now, anyone who's done portability has probably written these same 6 lines of code. And the tip-off there is not the windows.h. It's this guy right here, where absolutely 100% you have the, I need to enumerate files in a directory, and it's done one way on Windows with the Win32 API, and it's done a totally different way on basically every other system, the POSIX API. So let's go fix this. And there it is right there. In fact, that's the only one. Yep. The way DirkSimple works is you can just run the from the command line with no command line arguments, and it will look in the base path of the path where all its data is supposed to be, and say, are there any OGTheora files here, OGV extension files? If so, first one you see, let's assume that's the one they meant to run. The theory being that if you only have the one thing, you can just run the program, or if you're packaging it in some kind of GUI thing, you can just click the icon and it'll figure out what game you're actually running. But yeah, sure enough, you know, there's the Windows version up there with all the disgusting Win32 API calls, including having to switch between 2 different character encodings with the strings and stuff like that. And then in the if def else, there is the POSIX version, which basically does the same thing with a totally different API. So SDL3 has a better solution to that. It's basically written that code for you. Enumerate, if I could spell, rate directory. There you go. SDL enumerate directory, which you basically just tell it where you want, what directory you want to enumerate, calls a callback function for each item it finds in that directory, and there's your user data for that. And then that callback can do some control stuff. So let's go ahead and solve this problem. Just look for an OVG file in the base dir. We're going to call this now. Now, this does return a true or false to say whether this enumeration failed for any number of reasons, but we don't care about the result of this. If this fails, it just fails in this case. We're just going to go on. Game path will still be null, so we won't care. Okay, so this is looking in... Let's just get rid of the Windows code. Honestly, it's too much to look at. Goodbye. So it's just the POSIX code now. We want to look in this directory, basedir. We're going to have a find OGV, find movie files. Let's call it find movie files. That'll be the name of our callback, and the user data will be, what is it called? Game path. No, let's do found path. Found path is the thing we allocate, because game path might be not allocated for whatever reason. So let's do that. Found path. And this thing will allocate, our callback will allocate that if it needs to. Alright, so this is the thing that's going to become our callback, so we're just going to do it like that. Okay. Game path equals found path, which might still be null, but we check it right here. So if it doesn't find a file, that'll still be null, and it'll deal with that. But if it does find a file, or if it doesn't, it'll try to free this, and that's okay. Everyone's happy with that. Okay, so find movie files is what we're going to call this. But I also need to know what the signature is for the callback. There it is. Very helpfully documented for us. Static immunization result, blah, blah, blah. What did I call this thing? Find movie files. Movie files. Okay. Now, we obviously don't have to open a directory because that's the whole point of this thing. We don't need to do readdir because this is basically, effectively, this callback would be called once for each iteration through here where readdir is not null. So, the first thing we need in there is going to be dent dname is null. That would just be fname, so that fname, cool. Move this over as we go too. So if there's a presumably extension on the thing, and that extension is OGV, which is the augtheor extension. Let's do string case compare on that. There's no reason not to look for capitalized versions of that. Also worth knowing, in SDL3, this is string case compare only deals with low ASCII case comparisons. There are no concerns about locales doing weird things that are surprising to you. It's only low ASCII stuff, A through Z, basically, that it'll worry about case on. We do also offer something called UTF-8 case compare, which does like full Unicode case folding, and it can handle all sorts of wild stuff. But we're only looking for this string, so this is faster and easier. So that's what we're going with. All right, so blah blah blah. Oh, okay. So this is the thing that I think this is just a lot of, like, I learned to allocate strings like this that we're going to then sprintf to many years ago when I was very young, when I was first learning C. Like, add up all the different things and make sure you leave space for the separators and the, null terminating characters. And this is so dumb. Let's not do that. If SDL asprintf SDL, this is just a wrapper over the C function library, asprintf, where basically you just say, okay, figure out how big this format string is going to be, allocate the thing, and write to it. Does all this gobbledygook steps in just one function for you. It's just, a better way to do it. So we want to put that into found path. Oh, that's right. Let's do that. Char pointer, say p found path. Say this is definitely a pointer to what will be found path in there. Char pointer user data. There, now we have it. P found path, and that will initialize that and allocate stuff as necessary. And you don't have to tell it how big it is because it'll figure that out and allocate it for you. We do need these, so done, but this is not dname anymore, it's now fname. Yeah. Equals -1. So if we are out of memory, let me see what these return. Continue, success, or failure. Okay, this is just... Basically, the idea with this callback is that it runs once for each file in the, or whatever, entry in the directory that you're enumerating, but you can stop it sooner. Let's do that. There we go. You can stop it sooner to either say, I found what I wanted, so just stop looking. There's no need to enumerate any further. Or you can also say, I had a terrible failure here. Stop looking because everything went wrong. And this will decide whether it returns a true or false from the enumeration function. From, where'd you go? From this thing down here. Whether this returns true or false. It can return false if it had a problem enumerating, but also if your callback was like, there was failure. But okay, so let's see. So if this runs out of memory, it'll return failure. What are you going to do? You're going to crash in a moment anyway. But all of this garbage can go. Dun-dun. You don't need to close the directory because it's handling that stuff for you. Dun-dun. That'll set it up and put to the pointer we gave it. Okay, so that means you can just return SDL2, what was it called? Success? Yeah, success. Because we didn't run out of memory and it would have done the copy. So cool. And then, of course, if this was not an ogvorbis file, you want to return num continue, which says just get the next file from the next entry in the directory and call my callback again until you run out of things to call it with. And we can simplify this even further. Say return, if this thing return -1, then do it failure, otherwise do success. I mean, why make it more lines? That has to be. And that's that. Okay, so find movie files, blah, blah, blah. And down here, it calls that. Where'd you go? Yeah, right there. So we had all of those lines of code, whatever, it was like this for like, you know, that much code for the Windows version versus the Linux version. Now it's been broken down into one line here, and then a callback that is 1, 2, 3, 4, 5, 6 lines long. That's a definite, and it works on both platforms without you having to write any platform-specific code, which means we can also delete this obnoxious pile up here. Gone. So that's a huge win, that's SDL is doing the heavy lifting on that for you, and it's fairly pleasant to use. All right, let's see if that'll build. Because I probably got it wrong, right? I did. Of course I did. Baster is not. Oh, the callback passes in the name of the directory you asked it to enumerate to, so it's available to you. You just got to use the right name. There you go. Yeah, okay, cool. Let's see if that fixes it. Yep, okay. Now, I'm just going to run DirkSimple. The only file in here is layer.ogv, so it'll figure it out from that. So we can just run it like this, and if it works, it'll still run Dragon's Lair. There you go, it worked. So, hooray, so that's one less piece of garbage in here we have to worry about. Let's see. The other thing I want to talk about in here, one of the other things I want to talk about in here, is the audio. Let's do this the right way now. I want to get rid of this audio callback. Whoop, come back. Here we go. Audio callback. There you are. None of this is necessary. This is a very fancy way of doing a dumb thing. SDL lets you have multiple audio streams and bind them all to one audio device, and it will handle mixing all of it. So it's absolutely stupid that we are sitting here doing our own mixing and all of this tap dancing when we could just simply say, here, play this for me. So let's go get rid of that. First things first, after having spent the time to turn this G audio device ID into an audio stream, let's turn it back into a device ID. G audio device ID, which is why I did not rename this before. SDL audio device ID. 0 is kind of the null device ID. It's an integer, it's not a pointer or an object or whatever. So now that we're going to go back to open audio device. Come back here. What is the parameters for that? Now, there are no callbacks on this. You can assign a stream to it and give a stream a callback, which is more or less what Open Audio Device Stream does. But this is very simply open a device with this ID and this specification, which is optional if you do not care, because the audio streams will convert for you. But if you're mostly going to be in the same format, you can request a specific thing to say, try and get as close to this as you can, just for efficiency's sake. Alright, so we already have the device ID is just play default whatever, and we already have a spec, so we just gotta get rid of the callback. Gone. Audio device open failed. Cool, we got that. You no longer have to resume this on open, because the not simplified version, not the open device stream one, pauses the device right away so that you can set your thing up before a callback fires. But when this won't play anything until you bind an audio stream to it and put some data in that audio stream. So there's no need to pause it. You're in control of what you feed it. So the device is open. We have our Laserdisc audio stream. Let's just bind that right away. Let's bind audio stream, device ID stream. Okay, so SDL bind audio stream. What format? Okay, so G audio device ID, and was it G disk audio stream? Did I get that right? I think so. All right, so now that's ready to go. Now there's nothing, since we've just created this, there is no data in it. So even though it's bound, it'll every time it goes, the hardware wants more audio to play. This thing will be like, I don't have any audio, and it'll be like, okay, so we're just playing silence. It's fine. This does not have to have. This can stay bound with no data in it. That's totally okay. So we'll just leave that like that, and that should be good. But we got to go. Oh, device ID it's an integer again, so we'll put that back to 0. Let's put our close audio device back in here, and okay. There's no callback anymore, so we do not have to have a separate mutex for this. This linked list will only be touched when we touch it, and DirkSimple only does that from a single thread. There is no audio callback running in another thread, so no more lock can go away. And that's the last reference to the audio device ID, so cool. So let's go look at what we got here. What was it? Disk audio something. Disk audio, what was that? Yeah, disk audio stream, that's what it was. So let's do that. Okay, this is our audio callback. We're going to get rid of this in a moment. But the thing is, what we're doing in this audio callback, we're like, get more data from the stream. It's doing that automatically now. We don't have to manage that anymore. SDL is going to just pull data from it as it needs it. And we're just going to feed data to it as we have it, so. Going on without sound, okay. It's bound, put audio stream data. That's where we add more Laserdisc audio. That's where we clear it. You can do that. You don't need a lock because it's going to handle all that locking for you. And then we clean it up, and that's that. Okay, great. So now we just need to deal with these playing waves. DirkSimple wave is, where'd you go? There you are. Just a lot of information about it, including the raw audio data for the whatever bleep or bloop it wants to play, and a platform handle, which is if you want to, assign it to something. But for our purposes, this is the linked list of things it's playing. We're just going to change this to be an SDL audio stream, like that. We don't care how far into it are because we're not managing the mixing ourselves anymore. We don't care what it is beyond that. Playing wave. Let's go look for things that are called that. That's our linked list. That's fine. We might need to steal a little piece out of this in a moment, in the audio callback, it would go through that linked list and mix in each thing that was playing and update the state to say move past that, so we mix the next piece next time you need more data. And then we clean up. We're going to worry about that later. When we shut it down, when we shut down the whole process, we clean out any that are in there. So let's do that while we're here. SDL destroy audio stream G playing waves stream, and it's just streaming next. So there's only 2 things in it right now, so that's fine. and then we have where we add stuff. Okay, so we're going to keep the linked list because it's good to have a pool of audio streams that are playing. And when they're done playing, it's good to have a pool of available audio streams. So we're going to keep the linked list, but we're going to do it like this instead. Let me go steal that for loop from the audio callback. There it is. Done. Oh, there's really not much to it, is there? Okay. Just do this. Playing wave. I don't even know if I need any of this that's in here. Okay, let's just forget about that and go back. Go find my thing here. Playing wave. There's okay. So what we're going to do here before we just add a thing to the linked list, because the thing is, DirkSimple doesn't play a lot of sounds. It's a lot of bleeps and bloops, and it's usually one at a time, maybe two. You know, depending on the game that's playing, it might be another thing depending on the deal. But Dragon's Lair is literally one beep or bloop at a time. So, wow, PW does not equal null. So what we're going to do is we're just going to go through the whole linked list. And we're just going to see if SDL... Oh, what is it called? Get audio stream available. Yeah. Okay. And that's just really all there is to it. Okay. If SDL get audio stream available, PW stream equals 0, that is to say that there's a stream here, but it's already played everything that's in it. It means it's available. If 0, it's free to reuse. So if it's 0, then that's our thing. We're just going to say that's the item in the linked list we're going to reuse right there. Otherwise, go on and look for the next one until we either run out of things or we find one. So if PW equals null, need a new audio stream, and then we can do this. DirkSimple X malloc is just malloc, but it will just shut down the program if memory runs out, if we fail to allocate memory. Because really, what are you going to do when malloc fails? So playing wave equals da da da. Okay, and then so you don't have to check if it's null because it's never null. If the program is still running, then it's not null. So PW stream equals SDL create audio stream, and this was just spec and spec. What is the spec? This always comes through in the same format as the Laserdisc audio. Okay. Audio spec. Oh, and I keep track of the channels, but not the frequency. Okay, let's change that real quick. G audio channels. Let's just actually make this a spec. We'll keep the whole thing in here. Spec, G audio spec. Just like that. Alright, this callback can go. We're done with this. It offends my eyes. Goodbye. No more audio callback. It's gone. It's done deal. We don't need to save that there because we're going to turn this to G audio spec. We'll just keep it like this. Spec with G audio spec. Yep. Good. And then we have a global that just keeps track of that for us, so we have that information elsewhere. So that's good. Let's make sure, yeah. Channels. Alright, that'll do it. Okay, so now we can go back to what we were doing, which is PW equals this. Okay, so create audio stream, we can just do G audio spec twice. Actually, let's just do G audio spec like that. We know what the format is that we are going to feed it data in, but we don't know the output format yet. But when you bind this thing to an audio device, it will automatically set this thing to the format of the hardware. So no need to set it here. In fact, if you do set it here and the hardware's at a different format, it's just going to have to change it. So just leave it null for now. If PW stream equals null, Oh well, just free that. Didn't work out. PW and return. Sorry, we will not play that bleep or bloop because something went wrong and life is just like that. So fine. Alright, so we got that in there. Cool. We create the audio stream. And then we need next. That's the next thing. We already did this right here. Next and that. So cool. And then PW is definitely set, so we can get rid of this stuff. We know there is a PW and that it has a stream, so now we can just go SDL, put audio stream data, PW stream, wave, what was it called? Wave PCM, pulse code modulation, in case you're wondering. And do we know how big it is? Num frames. Wave num frames times G audio spec. Because we gotta break it down from frames to bytes. Channels. Do we have a thing that does this for us? Hang on. SDL include SDL. Alright, we have byte size, which we're gonna need from the format. Do we have one that'll do the whole thing for us? I don't think we do. Okay, so the actual byte size is the byte size of the format. Where'd you go? Like that. Where'd my thing go? Oh, there it is. Okay. It'd be the number of channels times the byte size of the actual format, which is G audio spec format. And then the number of frames, and that would turn the thing into bytes. Alright, cool. We also, by the way, do not care if this fails to put stuff to the stream. If we just don't play it, we don't play it. It's fine. The next time we go to play something, we'll find a stream with no data in it, and we'll just try to reuse that one. Otherwise, it'll sit there idle, and that's okay too. Flush audio stream to say we are not adding anything else to this stream. If we do, it'll reset this, but this says everything that's there, don't hold any of it back, play it all. Otherwise, it might hold a little bit back to help with resampling later, so you don't get audio artifacts. We're saying the whole set of data is there until I try to push more later. So, alright, so that should be all that needs. And then every time it comes through here, it'll create a stream. No, we got to bind it. That's the thing I forgot to do. Let's do that real quick here. Else if SDL bind audio stream to G audio device ID is the thing we did before. That stream. If not that, let's just give up on the whole thing here, just because it's going to be a weird state otherwise. SDL destroy audio stream, PW stream. Just nuke the whole thing from orbit and hope for the best and try again some other time. Cool, cool, cool. Alright, so that's bound. That'll set the data format. As soon as we put the data there, it'll start mixing it into the audio stream with the Laserdisc stream that's already bound and anything else that is playing. And when it runs out of data, it'll stay bound, but it'll just go idle. It'll have nothing to play, so it won't try to mix anything in until I come back through here and say, hey, this thing has nothing playing, so I can reuse it. So we get a nice little cache, a nice little pool of available audio streams as we go. Okay, so in theory, that should do it, right? Let's try and build that. See how we do. Oh, it's always terrifying when it compiles on the first try, right? And the thing is, all this should show you is that we should have less code but doing the same thing, which say you should hear the audio disc, the Laserdisc audio playing, and beeps and bloops mixing over it. I hear the audio.
Dragon's Lair.
Dragon's Lair. Alright, we're gonna let that go. And then hit... Oh, nope, something crashed. Oops. Let's try that one more time. What happened there? Let's see why that crashed. Okay, let's see. Play wave cold. See, and this is why you don't do release builds. What does cold even mean? I don't know. try that one more time. Debug build, so I can actually have like debug symbols. Awkward. You have to use the debugger while recording. Alright, so this thing blew up because I did what dumb thing? PW is null. Why is that null? Put audio stream data. Why is that null? Oh, dumb mistake, dumb mistake. I declared a rookie mistake. Cut and paste error. I declared another variable in another scope with this instead of using this one, it made a new one which went away as soon as the if statement was gone. So awkward. Okay, so that'll probably fix that. Excuse that little accident there. Okay, let's try this again. Okay. There we go. And then I can mix beeps and bloops into it, so... Dun dun dun! Is this gonna be the time? Let's find out. Come on, baby. Oh, so close! Alright. I'm getting across there at some point. Okay. So we're at a little over an hour now, but I want to show you one more thing since we're here. I didn't think this video would be this long, but we're here, so let's do it. Inscription is the bane of my existence. If you don't know what Inscription is, it is you can compile C code for a web browser, and it runs with WebAssembly at almost native speeds in a web browser, which is honestly super cool. But the problem with Inscription is that you end up doing things like this. Where'd you go? You know, this is at the very bottom of main, like an ANSI C main, where it's like, if we're in scripting, do this thing. Otherwise, just call this function in a loop, and when we're done calling this function in a loop, clean everything up and return. Inscription set main loop basically kills the main function. We're at the very end of it anyway, and then calls a function called inscripted main loop over and over again. Even though to your program it looks like main return, there's still a function that's firing at a regular basis. So every time it needs to basically render another frame of animation. So SDL has a thing, SDL3 has a thing where you can get rid of this. We have a whole document on how, you know, an SDL program starts, which is kind of pretty wild when you think about it. But there's a thing in SDL3 called main callbacks, where, like I just described there, this is what a regular program tends to look like. You have your main thing here, you do some setup, you have a loop where you check for events, you do one frame of stuff, and then you just keep doing that until it's time to quit, and then you quit. So SDL3 has an option that instead of building a program with this, you can build something with 4 functions which operate as callbacks. And you do it by defining this thing. And I should have done this, I should have included this file, by the way, in a proper SDL3 program. Not necessarily this defined, but SDL main is no longer a static library you link against, but is a single header library that you should include from exactly one file, wherever you include your main, and then it'll deal with things like WinMain and stuff for you on Windows. But we also want to use this main callbacks thing, so let's get rid of that real quick. There we go. And this basically says, once you define this function, you no longer give it int main like that. In fact, if you try to, it'll probably not compile. Instead, we're going to take this main function and we're going to break it into several sub-functions here. And on those functions, where are you? App init, blah, blah, blah. Okay, I'm just going to do it like this. So SDL app init, we actually have man pages, not in README, wrong directory. We actually have wiki documentation for all this too. So we're going to call this. This function gets called at startup. Now, normally you'd have main argc argv. This is going to look very familiar because you still have argc and argv. You also have this thing called app state, which we're going to ignore. That's basically, if you don't want to use global variables, you can take this moment in this function to allocate a structure, and that will be given to you on each of the callbacks, and then you can free it at the end. But instead of using globals, but DirkSimple uses lots of global variables. There's really no reason to stop using them here. And this is going to return one of three things through app result. It's either going to return failure, success, or continue. So this is a lot like enumerating directories, right? Success says terminate the program and tell the operating system it was a success, which in Unix would be return. You get an exit code of 0. Failure is the same thing, except exit code of 1, or whatever that would be on Windows, And then continue says just keep running the program, don't terminate it. So the nice thing about this is that, logically speaking, most games that switch over to this can just do this. Figure out where to cut. There's all our setup stuff. And then right here, that's probably just right where you cut right there. Return SDL app continue, so it'll continue on to the rest of the thing after initialization. And this we're just going to get rid of. Boom. Because the rest of this is sitting somewhere else already, which makes it super easy. But more or less, that's what your main looks like now. And then the actual main loop that runs forever while the program is being a program goes somewhere else. Okay, so that's app init. The other two that run are app event. There we go. We handle events somewhere in here. There we are. Let's do it right there. Oops. Okay, like that. Now I don't need E anymore because, let's call this E just so I don't change all of them. This function gets called once per new event that has come in, so you only have to handle one event per time this function fires. It might fire a whole bunch of times in a row, but each one signifies a new event came in. And now these do not come in other threads unless you run another thread and push your own events. So these will run in serial with the actual main loop iteration stuff. You do not need to pull events. In fact, you shouldn't, because it's handing you an event right here. So let's go through here and change all the E's. These are now a pointer instead of an object. So let's just do this real quick. That's it. Okay, so go back up here. Now, you saw me do this in Quake 3. I don't have, this editor does not have a nice way to just change the indentation or anything, but this is good because this gives us a chance to look through each of these real quick and make sure they're still sane. I'm not going to get into all the details of how this works, but we'll go through it real fast. Also, it lets us catch things like this. This no longer returns false. False is what we used to say, please terminate the program, but now we can just say SDL, how do you call it? App success. Please terminate the program because they hit the escape key. We're probably going to remove that later, but for now, we're not designing a program here, we're just porting it to SDL3. I know I need a better editor. You can all just sit here and just enjoy this as like a Zen thing, right? Okay. We just have a bunch of key handling code here to do magic things like save state and stuff. Nothing super fancy. I probably shouldn't have taken the time to indent this because we're at an hour and 12 minutes and you're all probably getting antsy. You probably have to pee, you probably have to walk the dog. Maybe this is your lunch break and you're at the end of it, and I apologize. We're almost there, I promise. Your boss will understand. Tell him this is actually you're learning a new skill today, so you're becoming more marketable to his whatever he needs. And if he doesn't like it, you're becoming more marketable. Just go get another job. Screw that guy. Okay, almost there. That was all the keys. Well, except for key up, I guess. I'm sure I'm still in the right place here. Yeah, okay. Oh, man. Okay, almost there. Starting to get carpal tunnel. I mean, I guess these events, I was like, this feels like too much code to be an event handler, but, I guess you gotta put it somewhere, right? Trying to, find a rhythm in my keyboarding here, so. Okay, I really should change that to gamepad, because the naming changed on SDL3. And here's another return, so let's do that one too, SDL app. Success, please terminate the program. Cool, and then that can go. And then this is a good place to split because that's where the event handling ends. So we'll just say return SDL app continue. The program should not terminate. We accept your event. We're moving on. And then second to last one here. Where'd you go? App iterate. This is where your main logic happens. This gets called relentlessly every time it wants to do a new frame. On some platforms, this runs as fast as it can. It just calls it as relentlessly as it can. On others, it might, like iOS and Inscripted, it might only call this when it wants a new frame of stuff. So be prepared for time to go, not necessarily as fast as possible. It might go at exactly 60 times per second or whatnot like that. All right, so this is all this, and it's very simple. We just call our cross-platform tick function, which will do all the magic. So app continue. We don't ever quit the app from this thing. We could quit it in response to events. All right, now this can go away. You know what? This might be a bug from SDL2 we were working around, but let's hold on to this code for now. But this can take a hike. You don't need any of that anymore. That's the thing that basically do this. Deal with going full screen size. We'll just keep that for now. It's fine. And then finally, one more to get, which is not there. I don't know why that doesn't link. App quit. This is always called at the end one time, right before the application terminates. Whether it's success or failure, when it terminates, it calls app quit. And I have a function already that I call to shut everything down. What is it called? Shutdown. There it is. Main loop shutdown. We're just going to take that thing right there. This is where you'd want to free this if you'd used it. We didn't use it. So it'll always be null. And this is whether you said success or failure when you asked it to shut down. And then this is just the same shutdown code. You don't have to set things back to null when you do this, because this is literally the last thing it does before it terminates the program. Done. Cool. Yeah, you don't really need to do that either. That's fine. You do not have to call SDL quit from this too, because it will call SDL quit once this function returns. Which, if you want to get pedantic, there are a lot of things in here you do not need to actually destroy yourself, because SDL keeps track of a lot of the objects it creates, and it will destroy them for you when you call SDL quit. But for completion's sake, it is safe to destroy them yourselves too. So, if you want to be really a completionist about things, it's okay to do that. But this is really the magic we needed. Was this and some other things to free that SDL doesn't know about. Okay, so that's that. That's those 4 functions, and it'll call it relentlessly. Let me see this. As you can see, we no longer have a function called main. It's gone. We'll look for it. Well, use main callbacks, but nothing in here. So let's build it and see what happens, I guess. Oh, yeah. That was naive of me to do that. Okay. Ninja. Unused variable controller input bits. That's right. That actually was app iterate. That moved to a different function. There we go. And that fixed it. Okay. So, same thing, but it should still run even though we don't have a main function anymore. And it does. And it still beeps and stuff. Okay. So that's good. No longer needs magic code for Inscripted, and it can do things more efficiently, like iOS can just call animation callbacks. And oh man, every time, Dirk, what the heck? But now that we can do that, we can. Do I have that? No, I don't. Okay, hang on. We can build an Inscripted version of this out of the same code base without those if-defs, and it will work. Build tools. Give me 1 second here. Linux, AMD64, EMSDK. I'm trying to memorize wildly long paths here. Okay, so now I have. Okay, now I have the compiler. So buildbot EMSDK. So now it would be emcmake. CMake, Jinja, blah, blah, blah. See what it does. Oh, we do not have... so the way the CMake is finding SDL3 is it's looking with package config. Yeah. which is a Linux thing that is finding SDL3 installed system-wide for me, but that's not going to work here. So I'm going to make a wild little SDL hello world. I'm going to cheat on this one. We have a little hello world module on a repository on SDL's GitHub. Just say like, here's a very bare bones like SDL3 application if you want to do it, and it does this thing. I'm just going to try this and see if it works, because I don't really want to try and mess around with building this separately. Okay, so this is what's blowing up. It didn't like find package, so we're going to do this. If mscriptin, let's just do that. Just pull it down from GitHub. Just do it. Otherwise, you have to find SDL3 like that. If, and then we need to make one change here. You don't do this anymore. You don't do this anymore. You just do SDL3, SDL3. I think that's all you have to do. This is going to be wild if this works. Do not try this at home. This is not... There are probably better ways to do this, but right now SDL3 is not in Inscriptin's repository, so you can't just do like argument -s use SDL equals 3. It won't work yet. They will get there eventually. They just haven't done it yet, to my knowledge. So we're just going to literally pull down the SDL source code over here. Let's see if it'll work. What could possibly go wrong here? Let's see. Okay, let's try it. Let's see if it works. I don't know. Oh, Lord. It's thinking about it. So right now, it's not putting a message up, but right now it's actually downloading the source code through Git for SDL3. Which doesn't take as long as you think it would. There, it's done. Done. Cool. Yep. Okay, that's fine. Building a static library instead. We're all fine with that. Alright, so I'm just going to type Ninja and see what happens. Now, this is definitely going to fail at the end because we're going to have to add some magic to this. I'm going to just let it run till the end and then we'll do the last thing. Or maybe it'll work. I don't know. We'll see. But I'm going to have to do a little command line editing to make this actually do the right thing. But we'll just let that cook real quick. You can see it's compiling SDL sources right now as part of DirkSimple, which is kind of neat that works. It's pretty fast too, because the way Inscriptin works is it just parses all the C files and it doesn't compile them for real until it gets to the linking phase. It's called what do they call it? Inter process optimization? No, interprocedural optimization, and it'll basically say I can compile literally the whole program at once and hold the whole thing in RAM as one giant compilation unit, so it can do all sorts of wild optimizations that it couldn't do if it was just compiling and linking stuff. I am impressed that worked on the first try, but I need to kill that because I need to know the command line option, because there's something very important here that we need, which is this. Some of this could probably actually go, but we're going to leave it for now. But the one thing you do need to do is embed the data files so they're in the web page, and it's like a 400 megabyte movie file. So again, don't try this at home. Embed file equals, where is it? Buildbot layer.ogv, and it'll find that automatically because we did the enumerate directory thing. And it also needs the data files. Embed file equals data, yeah, add data. So there, now the files will be available to the web page. And there was one other thing I needed to do here. Oh, initial memory is too low. It needs hundreds of megabytes. Again, this is not the right way to do things, but it needs hundreds of megabytes to keep those files in memory when it first starts up. Memory equals, oh geez, 24. We're just going to give it the web page a gigabyte of memory because we're just living large over here. It's going to be fine. So there we go. And let's just see what it does. We need the output too. We need to change the file name so it makes an actual HTML page instead of just the JavaScript. Let it cook. Let's see what happens. This might take a second. I'm a little nervous. Are you nervous? I'm feeling a little nervous. Can't wait to see if this works. I don't... auto-resume, auto-context, and call it this weird thing. I don't think you need this anymore. I think we fixed that in SDL3. I'm just talking out loud while this is chugging along here. Like add run dependency. I don't think these are needed anymore. I think these might be old things that were in here from whenever I last messed around with this on a web page. Oh, it's really working on it. Takes a while to copy hundreds of megabytes of movie data into a web page. Oh, I hope it's going to work. We didn't just all sit here for nothing. We are just like 4 minutes away from this being longer than the Quake 3 video, so we gotta get this done. Come on. I hope this works. Part of the reason this is taking so long is not just the copying, but this is an optimized build because... Oh, there it goes. Because this is murderously processor intensive if you don't do it on a web page, in WebAssembly this way. Index, index, index. Okay, it's all there. So we just need a web browser of some sort. Dragon Ruby, HTTPD. Let's do that. 8080. Alright, so this should theoretically be able to serve this. Localhost 8080. Will it work? It's trying to load it. Oh man. Now, web pages don't make sound until you click on them, and SDL3 knows that, and it'll keep dumping the audio so it stays in sync. So, click on it. There it is. Okay. Scroll this down a little bit so we can see it. There we go. Come back. Alright, there we go. Let's see if it works. This is it. I'm getting it this time. Oh, come on! I'm like Charlie Brown with the football. Okay, you know what, though? It worked. It's running in a web browser, y'all. Look how cool this is. I love it. Okay, I'm going to hit escape, though. Okay, watch out, Dirk. Okay, it worked. That's all there is to it. We have done so much stuff in an hour and a half. It's ridiculous how much we did. The simple SDL2 to SDL3 port was done, but then we did all this other stuff. We got the encrypted stuff in there. We cleaned out this thing with the enumerate directory. That's a new feature in SDL3. We changed the audio to not do its low-level audio callback, but to just hand it streams of data and say, you mix it for me and figure it out and leave me alone. There's the audio callback's gone. Not too shabby. Not too shabby. It switched to all these things. That's good. I mean, a lot of this diff is because we changed the indentation on the event handler, too. All of that's gone. Look at that red. It's gone. It's gone. We're getting rid of it. The main loop stuff's gone. Beautiful. Diff. Workout line. 804 lines of diff for all these changes. That's not bad, considering, especially when you consider the indentation as part of it. The event loop indentation changing is a good chunk of that, so that's not too shabby. Alright, that's a lot of neat new features. We've improved this. The code is better. It does things easier and nicer and less ugly. I think it's a huge win. I'm pretty happy with it. If you'd like to play along with this at home, you need the data file, you need the movie file. You need to own a legal copy of Dragon's Lair to play it, but if you were to hypothetically go to something that was an archive on the internet, like an internet archive of some sort, and search for the term DirkSimple, I bet you could probably find the file somewhere. Alright, so I think we're good to go. This was fun. Let's try to do this again sometime, and maybe not take 90 minutes to do it. So, thanks for watching. Stick around. I'm sure I'll do something fun like this again later. Have a good day.